now we have completed which chapter we have completed? D and F block, isn't it? Are you there?
Yes.
Yes, ma'am.
Okay. So now we have completed D and F block elements, isn't it? So D and F block elements chapter is also there. Just after the chapter in NCERT book, which chapter is mentioned? D block, coordination compounds. Okay. Why is it so? Because it is intentionally given. Because before studying coordination compound, you need to understand basic information regarding the chapter from the previous chapter. Which is the previous chapter? D and F block elements. So hopefully you know something related to D and F block. I hope so. Okay. Am I right? Am I right or not?
Yes,
You know,
Yes, ma'am.
something means for example, you must know transition elements are capable of showing multiple oxidation state, or they are capable of forming coordination complexes. Okay, so why they are capable of forming coordination complex? Because their ionic size is small, and their ions having higher positive charge, like +2, +3, +4, +6, +5, +7 and all. And the last one is they have enough number of vacant orbitals to accommodate electrons donated by a ligand. So D and F block elements fulfill all these requirements. That's why here we will discuss the chapter coordination compounds. Okay. First of all, what do you mean by coordination compound? Coordination compound is a compound in which a coordinate covalent bond is present. What do you mean by coordinate covalent bond? Coordinate covalent bond. What is the meaning? Anyone can say, is it same as covalent bond or is it different from covalent bond?
There is a central atom which bonded with surrounding uh, atoms.
So what was my question? What is a coordinate covalent bond? It is a covalent bond. Ha, Poonam, correct. It is a covalent bond. It is a type of covalent bond. Okay, but what is the difference between normal covalent bond and coordinate covalent bond? What is the difference between these two? This is the elementary information regarding coordination complex. Anyone can say the answer? Okay, I'll tell you.
Ma'am, maybe something regarding stability.
Stability, they are less stable, of course, but it is not at all, stability is not there. Okay, wait, I'll tell you. Coordination covalent, it share its lone pair. Poonam, it is not exactly matching. Let me discuss it. So normally a covalent bond means what? What is a covalent bond? Anyone can say, Anne-Marie, what is a covalent bond?
A bond between a metal and non-metal.
Which type of bond is formed between metal and non-metal? Covalent bond?
No, ma'am, it is between two non-metals.
Very good, very good. It is between two non-metal atoms, first of all. So second is, it is formed, what is the procedure of forming a covalent bond? Poonam, what is the procedure of forming a covalent bond? What is the procedure? Means how a covalent bond is formed. Any information?
Ma'am, by sharing
Pair of
the electrons.
Very good, very good. By mutual sharing of electrons. What do you mean by mutual sharing? What do you mean by mutual sharing? Mutual sharing and sharing, both are same or different? Equal?
Ma'am,
No.
H2, Cl2, for example.
Okay.
मैम
Mutual
वो किसी का नहीं होता, वो दोनों का होता है.
दोनों का होता है, वो किसी का नहीं होती. हाँ, सही बात है. That is called mutual sharing. Very good. So, but here it is sharing. Sharing means covalent bond. The condition is shared pair of electrons are contributed by two participating atoms, like two participating atoms of non-metals, isn't it? Okay, but in the case of coordinate covalent bond, the shared pair of electrons are contributed by only one of the participating atom. This is the meaning of the term coordinate covalent bond. So coordinate covalent bond means the shared pair of electrons are contributed by one of the participating atom. And years back, there is a way of differentiating the representation of a coordinate covalent bond and covalent bond. Like covalent bond, we are represented by a line segment, isn't it? Line segment. If one line segment is between two atoms, like between hydrogen atom, one line is there, one line segment. It means a pair of electron is shared between two hydrogen atoms. Okay, and coordinate covalent bond, how to show, how to represent. It is represented by, it was represented by means of an arrow which is starting from the donor and ends with the donator, end with the acceptor. Suppose ammonia molecule contribute its lone pair of electron to platinum metal atom. So the arrow starting from ammonia, that means nitrogen of ammonia, and ends with the platinum arrow. So we can easily identify a coordinate covalent bond and covalent bond. But now that representation has changed. Now simply it is also mentioned by using a line segment. Okay, got it? It is also same. Representation is same, so you can't make out whether it is a coordinate bond or coordinate covalent. Okay, so this you need to understand first of all. So secondly, coordination compounds are normally formed from transition elements. Normally, okay, normal case coordinate covalent bond is formed between transition elements and ligands. Ligand means what? What do you mean by ligand? Write the definition of a ligand. Ligand. What is a ligand? Ligand is a species which is capable of donating at least one lone pair of electron to the metal atom. At least one lone pair of electron to the metal atom. Got it? Ligand is a species. You need to write it as a species which has a tendency to donate at least one lone pair of electron. Very important. So that means the ligand may be an ion, may be a neutral molecule. Okay, ligand may be an ion. Can you say which type of ion? Is it a cation or anion which is capable of functioning as a ligand? Anyone? Understand the question first. My question is it a cation or anion which is capable of function as a ligand? Anyone which is function as a
Cation.
cation means what? Cation carry which charge?
Positive.
Positive. So positive charge, what do you mean by positive charge?
Deficiency of electron.
Deficiency of electron. So that means cation has no extra electron at all, or it already lose its electron. Okay, so cation means it carry a positive charge, so it has a deficiency of electron. But anion normally having a charge negative and it has extra electrons. Okay, so ligand, there are two possibilities, either it is an anion or it is neutral molecule. Can you say example of neutral molecule which is capable of donating pair of electrons?
Water.
Water, very good. How many lone pairs water has?
2.
2, very good. So any other molecule which is function as a ligand, neutral molecule? Water has
Nitrogen oxide, nitrogen monoxide maybe.
nitrogen oxide is not function as a ligand. Why? Because there is a slight difference in energy between electronegativity between nitrogen and oxygen specifically.
न्यूट्रल होता है ना वो इसलिए.
It is neutral. Only NO can be function, not any other. CO, correct. Carbon monoxide function as a ligand. Ammonia function as a ligand, NS3. So there are some cases, it is not only these types, there are some other compounds also. They are capable of donating lone pair of electron. Anyway, understand ligands are of two types. H2S is not function as a ligand. H2O.
HCl.
HCl again not function as a ligand. What is the reason? Because HCl, even though it is a covalent bond, it has polar nature. Okay, something is there, some which compound which has partial positive and negative charge is not able to donate its lone pair of electron. Got it?
Yes, ma'am.
Okay. So this is the elementary idea regarding coordinate complex. Alfred Werner is a scientist who coined the postulates behind formation of coordination compounds, how coordinate bond is formed. So his theory is known under the name Werner's theory of coordination compounds. So there are 4 different postulates for coordination theory. So it is known under the name Werner's theory. So we'll discuss that theory first. Okay. So for that I am presenting. So first of all, I will off my camera so that it is clear for you. I am sharing. So Werner's theory of coordination compound, let us see. Video is also there. So I don't know whether it can be work properly or not. So first of all, let us check whether the 3D is functioning or not. Okay, it is functioning. Is the screen is visible to all? Screen is visible?
Yes, ma'am.
Okay, so let us play. Let us play, and you can say whether it is audible or not.
Coordination compounds.
Is it audible? Audible?
Yes, ma'am.
Yes, ma'am.
Okay, very good, beta, very good.
A coordination compound, also known as a coordination complex, consists of a metal atom surrounded by ligands.
So you can write this definition. Okay, coordination compound is also known as a coordination complex, and which consists of a metal atom surrounded by ligands. Which consists of metal atom surrounded by a ligand. This is the simple way of defining a coordination compound. It contains a metal atom which is surrounded by a ligand. So in the example, you can see that the metal is chromium and the ligand is carbon monoxide. And in this case, both carbon and oxygen are capable of donating lone pair of electron. Okay, carbon and oxygen. So let us see the
which include non-metal atoms, ions, and neutral molecules. Ligands donate electrons to the central metal and form coordinate covalent bonds, sometimes referred to as dipole bonds, with the central atom. An example of a simple neutral coordination complex is the diamine silver one cation, in which we see a silver metal atom bonded to 2 ammonium ions. When copper sulfate is mixed with concentrated ammonia, the coordinate compound tetramine copper 2 sulfate will be formed. Let's closely look at the reaction. Each NH3 molecule will donate a pair of electrons to the central copper atom, forming 4 coordinate covalent bonds. The tetramine copper 2 sulfate crystals contain 2 polyatomic ions, a sulfate ion and a complex ion. In tetramine copper 2, the sulfate is negatively charged ion. The hexachlorocobaltate 3 ion is a negatively charged ion. And diamine tetrachloroplatinum 4 is a neutral complex. While the transition metals usually form coordination complexes, some main group elements such as aluminium and tin will also form coordination complexes. Aluminium hexafluoride ion and tin tetrafluoride ion, hexa aqua cobalt 2, hexaamine nickel 2 and tetracyanonickelate 2 are also coordination compounds. Chlorophyll in plants, which is a magnesium complex, and hemoglobin in blood, which is an iron complex, are also coordinate compounds. Summary. A coordination compound is a substance in which a metal atom or ion accepts electrons and forms coordinate covalent bonds with neutral molecules or anions that are known as ligands. A coordination complex may be an anion or cation or a neutral molecule. Chlorophyll and hemoglobin are examples of coordinate compounds.
So I think from the video you can understand that how a coordinate complex is formed. So diagrammatically it was mentioned there in the slide. So by donating a lone pair of electron to the metal atom, and there also you have seen that the type of bond formed is a coordinate covalent bond, and it is represented by means of a line, or it is a line segment. So now let us think about the Werner's theory of coordination compound. That video was only an introduction part. Okay. Now let us think about the theoretical part of coordination compound. Okay. So coordination compounds have a central metal atom or ion surrounded by oppositely charged ion or neutral molecule called the ligand. So these two definitions we have already covered up. Central metal atom and its necessary condition to fulfill by a metal ion is it must have enough number of vacant orbitals so that it can accommodate lone pair of electron provided by a ligand. So the minimum condition for a ligand is it must have at least one lone pair of electron to donate to metal atom. Okay, so these are the two basic terms related to coordination complex. Now in the figure you can see a general representation, M representing a metal, A and B represent two different type of ligands. Okay, A and B are two different types. And this generalization is converted into a specific example, and here it is mentioned. So here if you want you can draw the structure or you can write the formula. So board we can't use now, so you can write it down. How to represent this compound? So CO means cobalt, NH3 thrice, Cl3, then put a square bracket in all this. So this is the way we can represent this compound, and its IUPAC name and all we will discuss later. And if you want, I will tell you the IUPAC name of the complex is triamine trichlorocobalt 3. This is the this is the IUPAC name. So no need to worry about IUPAC name. Now you can simply write the formula. Okay, CO, NS3, thrice, Cl3, then you cover the whole in a square bracket. So this is the way we will show a coordination complex. Okay, after stop the sharing, I will write it on the board. Okay, so that you can understand whether you can whether you have written it correctly or not. Let us verify also. Okay, so this is the first one we have discussed. Now, natural coordination compounds. Natural coordination compound, generally two natural coordination compounds are there. One is chlorophyll, which is present in plants, especially in leaves, and hemoglobin, which is present in the body, human body. And no need to remember the structure, but you know, first case chlorophyll, the metal part is magnesium, and hemoglobin, the metal part is iron. Okay, so the most vital biological components in nature and in our body are the natural occurring coordination compounds. Simply you write the example, hemoglobin and chlorophyll. Okay, now this person, Alfred Werner, he was a Swiss chemist. He first studied the structure and composition of coordination compound, and he prepared many coordination compounds, and all his observations and inferences he concluded in a particular form, and it is called the Werner's theory of coordination compounds. So you can write it as Werner's postulates. Postulates means the important analysis of Werner in the form of rules or conditions. They are known under the name postulates. So let us see the postulates of coordination compound. So these are the 4 postulates of Werner's coordination theory. So I will explain each one, and I will give proper example after completing the sharing. Okay, in coordination compounds, metal, you can mention these points, because points I can't dictate to you in the class. Why I am showing this slide? Because you need to learn the postulate as it is. Okay, as it is means you can change the language if you wish. Okay, you can convert it into simple language, no harm, but the points must be there. Generally, first one is related to speciality of a metal. So in coordination compound, metal atom shows 2 types of valencies. One is called the primary valency, and second is called the secondary valency. So the primary valency and secondary valency both belong to a metal atom. You can mention this. Okay, copy the same. While I am explaining this, you try to copy the same postulate. Okay. Second postulate is how to fulfill primary and secondary valency. So primary valencies are fulfilled by using only anions. Anion means negative ions. Secondary valencies can be satisfied by means of both anions or neutral molecule. Okay, here it is mentioned neutral ions, so that you can correct it as neutral molecules. Okay, and side you can write the example even. Negative ion you can write the example OH minus, Cl minus, Br minus, SO4 2 minus, CO3 2 minus. These all are anions which function as ligand. Neutral molecule you can mention the example NS3, H2O, carbon monoxide. More than these are there. It contains more than 2 donating atom, electron donating atom. So that needs structure. So that we will see later. Okay. So this is all about the second postulate. Third postulate is that every metal has a fixed number of secondary valence. So that means each and every metal, their secondary valencies are fixed. Secondary valencies are fixed. That means, for example, in the case of chromium, secondary valencies are fixed as 6. 6 are there. In the case of cobalt, again, secondary valencies are 6. This number is fixed. It can't change. But primary valencies can vary. Every metal has a fixed number of secondary valencies. Primary valency is non-directional, whereas secondary valency is directional. This is the last one. So what does it mean? Directional and non-directional. Primary valency do not govern the structure of the compound structure. So that means structure is decided only by secondary valency, not by primary valency. So that's why it is mentioned. Primary valency is non-directional. It has no specific shape. Whereas secondary valency is directional, means it has a specific structure. Like sometimes it is tetrahedral, sometimes it is square planar, sometimes it is octahedral. These are three major shape of secondary valency. That means coordination complex is these three. Which are they? Square planar, tetrahedral and octahedral. These are the three major categories. Okay. So this shape is only due to secondary valency, not due to primary valency. That's why it is mentioned in the fourth point as primary valencies are non-directional. That means it cannot be decided the shape of the molecule, whereas secondary valency is directional, which decide the shape of the molecule. So primary valency is directed towards a fixed position in space, means it has no particular shape. It has but a fixed position in space. This leads to a definite geometry to the compound. Okay. So you can there mention only one point. Fourth point you can summarize in this way. No need to write all these unbounded things. You need to mention only one single point there. Secondary valencies decide the shape of the molecule. Secondary valencies decide the shape of the molecule. That's all. Okay, no need to mention that primary valency, non-directional, secondary valency. So this is the question related to Werner's theory. Werner's four postulates are there. I will summarize all the four postulates. First postulate is that metal has two types of valencies. One is called primary valency and second is called secondary valency. Second is primary valencies are satisfied by means of anions, whereas secondary valencies are satisfied by means of both anions and neutral molecule. Third point is even each and every metal has fixed number of secondary valencies, but their primary valencies may be different, may be vary. And the last one is primary valency do not take part in the structure formation of a coordination complex, or secondary valencies decide the shape of the molecule. Any of these you can mention. That means primary valency is non-directional and secondary valency is directional. Okay, so this is all about the structure, all about the Werner's theory. Now I will give one more question there. You write the question. Differentiate between primary valency and secondary valency of a metal ion in a coordination complex. Or simply you can write differentiate between primary valency and secondary valency. How many points you can include under this category? You can say one by one if you wish. Which point we are supposed to say first? Anyone can speak.
Ma'am, primary valency is satisfied by only negative ions.
Correct. Secondary valency satisfied by means of negative ion and neutral molecule. Correct. Very good. Any other student say any second
Ma'am,
point?
primary valency is non-directional while secondary valency is directional.
Correct. Second point. Okay. Very good. Third.
This The shape of the compound is only depend on secondary valency.
Okay, secondary valency, but not decided by primary valency. Very good. One more point. Last.
Examples.
बेटा फर्स्ट पॉइंट देखो, उसमें एक पॉइंट है, प्राइमरी वैलेंसीज आर आयनाइजेबल while secondary valencies are non-ionizable. That I will explain in the class. Okay, with example I will explain what do you mean by primary, what do you mean by secondary, that I will tell you. Okay, got it? Let us continue for 1 minute. Let us see. Nickel. Here one example is given, NiNH3 6 times Cl. This is one example, NiNH3 6 times Cl2. Nickel has, this is the illustration of Varna's theory. Nickel has primary valency 2. Okay, you can write this example. Okay, which example? Write this example. All of you have to write this example. Which one? NiNH3 6 times, and there is a square bracket, and outside the square bracket you have to mention Cl2. So remember, primary valencies are always mentioned outside the square bracket. Look at this. Primary valency. That means NiNH3 6 times, this is in the square bracket. Outside is only Cl. How many Cl atoms are there? 2. So therefore we can say that for nickel atom, how many primary valencies are there? 2 primary valencies are there. And in the diagram, no need to mention the diagram. Draw the diagram. Here it is mentioned in dotted line. No need to go this much detail. Simply you must say NiNH3 6 times Cl2. Those ions, which ions or molecule, only ions are there because primary valency is satisfied by means of anion only. How many ions are there outside? See here the ion is Cl minus. How many Cl minus are there? Cl chlorine atom 2. Therefore primary valency is 2. And secondary valency means inside the square bracket, apart from the metal atom, which molecule is there inside? Which molecule is there? Ammonia. So ammonia as such function as a ligand. How many ammonia molecules are there? 6. So altogether, in this example, nickel has 6 secondary valencies and 2 primary valencies. Got it? I think it is clear to all. Now, according to the second postulate, primary valency is satisfied by means of negative ion. Perfect. Because here negative ion is Cl minus. Secondary valency is satisfied by means of either negative ion or by means of neutral molecule. And in this example, neutral molecule is given NH3 6 times. Okay, fine. Then coordination, this shape of the molecule is octahedral, because here nickel is bonded with a 6 ammonia molecule. That means it is a octahedral structure. You know the octahedral structure. Okay, and next point you try to remember, very important. It is in this particular molecule, when we add when we take the aqueous solution of this compound, then we add a silver nitrate solution into it, we will get a white precipitate of silver chloride. Okay, and at the same time, if we warm this complex with sodium hydroxide solution, we will not get any smell of ammonia. Okay, we will not get any smell of ammonia. So that means experimentally, when we prepare an aqueous solution, we can't separate ammonia molecule, but we can separate Cl minus. Okay, that means Cl2, this can be ionized into 2 Cl minus ions. That's why it is mentioned primary valencies are ionizable. And we can do it experimentally also. And experimentally we can prove that Cl minus ion is present in aqueous solution. Because when we add silver nitrate reacts with Cl minus, forming white precipitate of silver chloride. So it verified that Cl minus is free in the medium. Got it? This is the meaning of ionizable. And secondary valency is non-ionizable. Non-ionizable means when we perform test for ammonium ion, like heating with NaOH, we need to get smell of ammonia, but in this case ammonia is not separated. That means it is bonded with the central metal atom, and this bond is so strong it can't ionize. I think it is clear to everyone. Now I'm stop sharing and I'm coming back. Okay. So I hope this much is clear to you. So we'll continue with the same in the next class. Understood? Continue with the same, and next class I can't say when it will be. Anyway, Monday I will I will take only 3 minutes to say that how to conduct the oral test. Okay. So terms and condition I will tell you in advance. Why? So that when any problem is coming, you are not supposed to putting blame on anyone. Okay, conditions are, so in the oral test, one condition I had already given to you, but you people having problem in roll number wise properly. So now the goal is in my part only. So I have decided that I will conduct the test from Monday to Wednesday, and I will ask the question to any student. Okay, any student means you will be prepared. Okay, so first day I don't know how many students oral test will be over. In the first day I don't know, I have no idea. But let us wait for first day, and